Here's my y-axis. Here's my x-axis. I'm going to label my points, or my increments, 1, 2, 3, 4, 1, 2, 3, 4, -1, -2, -3, -4, -1, -2, -3, -4. Where is -1, -2? Janessa?
1 to the left and 2 down.
Good. 1 to the left and then 2 down. So it's going to be right here. Okay? Remember, your first coordinate is how much you move left or right. If it's negative, you're moving to the left. And then your second coordinate is how much you move up or down. So if it's negative, you move down. Okay? This is -1, -2. Where is 0, 1? Tessa?
In the origin of 1.
Good. Up 1. Just right here. Beautiful. Okay? If one of your coordinates is 0, that means that you're going to lie on one of the axes. Okay? So you're going to either lie on the y-axis or you're going to lie on the x-axis. If they're both 0, then you're at that middle point right in the middle. Okay? All right. So that's 0, 1. Where is 1, 4, Roy? 1 right up 4. Beautiful. Right up here. Awesome. And let me get a zoomer to tell me where 2, 7 is. Any zoomer, I'm going to pick you. Okay. Carlos, you're up. Where is 4, 7? Or 2, 7?
2, 7 would be 2 on the x-axis and 7 on the y-axis.
Good. 2 in the x-axis, that's right here. And then up 7, so 5, 6, 7 in the y-axis, all the way up here. Okay? This should be, if we did it the right way, a straight line. Okay? And if we draw as straight as Mr. Yuriko can get, beautiful. A little squiggly, but that's the best we can do. We'll deal with it. Very, very nice. Questions on the warm-up? All right, so objective. So our objective in this lesson is to write equations that represent functions. So before, we were always given whatever y equals mx plus b is. This lesson is all about finding out what it is on our own, okay? So we're going to be given a word problem, and you're going to be asked to write an equation based off of that word problem. It's pretty cool, and there's a 3-step process in order to do that. So go ahead and get that objective copied down, and let's get started. Okay, so problem number 1, we're going to write a function for this word problem. So you can estimate the temperature by counting the number of chirps of the snowy tree cricket. The outdoor temperature is about 40 degrees more than 1/4 the number of chirps the cricket makes in 1 minute. What is a function rule that represents this situation? Okay, guys, when we're looking at this problem, okay, the very first thing that we want to do is we want to define what our variables are, okay? So what are the variables? Okay, and we will have 2 of them in this section, okay? So in this lesson, we will have 2 variables each time. Okay, let's see if we can figure out what the 2 variables are. They depend on one another, okay? Roy, what do you think they are?
The temperature and the number of chirps.
Excellent. How did you know that?
Because it says you can estimate. So
Good.
you're like trying to measure it.
Very good. It says that we're going to estimate the temperature by counting the number of chirps. So those are the 2 things that are changing, right? One depends on the other. Okay, if we're estimating something by counting something else, those are going to be our 2 variables. So we're going to use T to represent temperature, and we're going to use C to represent the number of chirps. So what are the variables? Those are going to be T and C. T for temperature, C for the number of chirps. Very nice, okay? Our second part of the problem, okay? Our second part of the problem is we have to write down all the numbers. So write down all the numbers. What numbers do we have in this problem? Tessa?
You have 1/4.
1/4, good. What else? Alan? 40 degrees Fahrenheit. Is there another one? Victoria?
1 minute.
1 minute, good. Excellent. Okay, we've got 1/4, 40 degrees Fahrenheit, and 1 minute. And our third portion, okay, is we need to write an equation in the form y equals mx plus b. Where y is a variable, x is a variable, m is a number, and b is a number. Okay, so of our variables, guys, this is where it gets tricky, okay, when we're actually writing the equation. Steps 1 and 2 are pretty easy, defining the variables, what they are, coming up with letters for them, and then number 2 is just writing down all the numbers. This is where we have to put everything that we just found together, okay? So we actually wrote down 3 numbers, so we're not going to use one of them, and let's try to figure out which one we're not going to use, okay? Now, before we do that, which of the 2 variables, which one depends on the other one? What do you think, Ashton?
40?
Say it again.
40?
So we've got temperature and we've got the number of chirps. Which one depends on the other one? Does the number of chirps depend on the temperature, or does the temperature depend on the number of chirps?
Oh, the number of chirps.
Which?
It depends on the temperature.
It says we can estimate the temperature by counting the number of chirps. So we're going to have T equal C, okay? Because the temperature depends on the number of chirps, by counting the number of chirps. That doesn't make sense?
No.
Okay. The more we do these problems, the more you'll see it. Okay, if you don't see it right now, that's okay. Okay, so now we've got T equals C. We have to multiply C by something, and we have to add something to C. What do you think we add to C? Read the question carefully, okay? So around these numbers, we've got 40 degrees Fahrenheit more than, and then 1/4 the number of chirps that they make in 1 minute. Which one of these things do you think we add to C? Anderson?
No, 40 Fahrenheit.
40. Why?
It says more than.
Very good. It says more than. More than is our super important piece, okay? If it's more than, that means always that we're adding, okay? So we're going to add the 40 degrees Fahrenheit, and it says 1/4 the number of chirps. So we're going to multiply 1/4 by C. Because it's 1/4 the number of chirps the cricket makes in 1 minute. Okay. Go ahead and box that in. That's our answer. Okay, moving on. Guys, the more we do, the better we'll get at these. Okay, I want you guys over the next slide for now. Total revenue from ticket sales will depend on the number of general seating tickets sold. Write a function rule to represent this situation. What is the maximum possible total revenue? Okay, so what we have to do is we have to first identify what our variables are. Okay, so based on this problem, there's two things that will be our variables, okay? What do you guys think that they are? Roy, give me one of them.
Total revenue.
Perfect. Total revenue. Okay, that is what we're trying to find. It says that the total revenue from the ticket sales will depend on the number of general seating tickets sold. So remember, variables depend on each other. So what's our other variable?
General seating.
Not general seating.
Or tickets sold.
Tickets sold in general seating. So the number of general seating tickets sold. So we're going to put tickets sold. Okay? So we're going to label total revenue as R and tickets sold as T. Okay? Because remember, variables are always going to be our letters. Okay, our first thing that we're supposed to do is write a function rule to represent the situation. Okay, now we are given some numbers, right? We're given some numbers down here. Okay, so what we have to do is we have to write down all of those numbers, right? So number 2, we're going to write down the numbers. So reserved seating, it was $25 for 10 rows and 12 seats per row. What was the revenue here in reserved seating? Anderson?
3,000.
How'd you get 3,000?
I multiplied the rows by the seats,
Mm-hmm.
and then multiplied that by 25.
So 10 by 12, which gave you 120, and then you multiplied it by $25 per seat, right?
Yeah.
Which gave you 3,000 in total revenue for the reserve seating. Remember, these seats are already paid for. It says that they're sold out. So we already made this fixed amount, $3,000 in revenue right off the bat. So that's our first number, guys, okay, is $3,000. Now, the tickets sold in general seating, that will tell us how much our total revenue is going to be, right? How much is a general ticket sold gonna be? How much money are we gonna make off of those tickets?
In total, or just?
Nope, just for one ticket. If we sold one ticket in general seating, how much would we make? $10. Okay, that's gonna be our second number. So $10 is our second number. Okay? Knowing this information, guys, let's go ahead and write an equation, okay? So step number 3, we're going to write our equation. Which is going to be y equals mx plus b. So now total revenue, remember, total will be your y, equals, and we have to relate it to t. What are we going to multiply it by t? Are we going to multiply it by 3,000 or $10? What do you think, Roy? $10. Why?
Because it's per seat.
Correct. It's per seat, right? Because each ticket is going to be $10. So we're going to make $10 per seat. So this is going to be multiplied by $10. And then are we going to add? What are we going to add? The 3,000 from the original seating. Ay is right. This one was a hard one, okay? Now, there is one more part to this question. It says, what is the maximum possible total revenue? What do you think, Anderson?
You want me to explain how?
Yes.
Okay.
Mm-hmm.
So you multiply 30 times 16 to give you your total number of seats, which is it'd be 486.
Mm-hmm.
And then you multiply that by 10 to $13 per seat.
Good. And then you multiply that by 10, and you get 4,860. So if the total number of tickets you could sell is 486, your revenue is going to be, this is max, okay? Your revenue is going to be $10 times 486 plus the original 3,000 that you made from the reserve seating. So revenue is going to be 4,860 plus 3,000. So your total revenue maximum will be 7,860. Very nice. You guys, I know how difficult this question was. Okay? The only way we get better, though, is to do these tough questions and to be exposed to them. All right? The ones on your homework, I think there's only one that's like remotely close to this difficult. Okay? The rest of them are pretty easy. Yeah. When you're done copying these notes down, I would like you to submit them. And then I want you to start on your homework. You still have about 10 minutes. You guys can get a lot of your homework done in 10 minutes. I want you to go down to the lesson check, okay? We're going to do number 1 together. The total cost C for P pounds of copper in each pound costs $3.57. Our first step for number 1 is to identify the variables. What are the variables? Our variables are C and P. Step number 2, write down all the numbers. What numbers are we given? Anderson? $3.57. Okay? So we're only using one number now. Okay? We are not given a second number. We're only given one number. Okay? So now step number 3 is we're going to write an equation in the form y equals mx plus b. Okay? Remember how I said if something says total, you want that alone on one side of the equation? So it says total cost, C, so we're going to put C by itself on the left side, equals. Now, are we going to add $3.57, or are we going to multiply $3.57 by P? What do you think, Tessa?
No, we're gonna multiply.
Why?
Because it says each pound.
Very good. Each pound. So we're going to take $3.57 and multiply it by P. So in this case, our B, right, is 0. Okay? In this case, our B equals 0. So we just leave it as C equals $3.57 times P. Okay, let's do number 2 as well. Okay, so number 2. Number 2 states that the height F in feet of an object when you know the object's height h in inches. Okay, so we're going to write an equation that represents that. Number 1, what are our variables here? F and h, where h is the height in feet, and F is the height in feet, and h is the height in inches. Are we given any numbers? No. Okay, we're not given any numbers. We are going to use a number, though, when we're writing our equation. Okay, step number 3, we have to write F equals h. Now, if you were given an object that was 12 inches tall, so h equals 12, how many feet would that be? 1. So F equals 1. If you were given an object that was 24 inches tall, how many feet would that be? Yep, F equals 2. So what do you think we should multiply or divide by to h to make this equation true? What do you think, Tessa?
Wait, divide like 24 divided by 2.
Yep. Not 2.
12?
12. So all it is F, the number of feet, equals the height in inches divided by 12. Right? Because, if you think about it, there's 12 inches in a foot, right? So however many inches you have, you divide it by 12, and that'll give you how many feet you have.
So if we got a question like this on the quiz, how would we put in the answers?
So this would be like a free response question. So you would have to write it out. Or it would be multiple choice. So you would be given like F over 12 equals H, F equals H over 12, and you have to figure out which one's the right one. Okay? All right, number 3. The amount Y of your friend's allowance if the amount she receives is $2 more than the amount X you receive. Okay? What's step number 1? Find the variables. What's my variables, guys? Y and X. Very good. Are we given any numbers? $2. Let's use them to write an equation. So we're going to write in the form y equals mx plus b. Okay? So the amount y of your friend's allowance is the amount she receives is $2 more than the amount x you receive. So y equals x. What are we doing to x? How are we using that 2? You're adding it. Very good. How did you know to add it? It says more than. Okay? It says more than. So we know we're going to add the 2. So it's going to be y equals x plus 2. Again, guys, a lot of this does not come supernaturally. You have to practice, practice, practice. Roy, what's up?
Why didn't we use the formula before? Because it didn't give us like numbers.
Why didn't I use what?
The formula in number 2.
Oh, in the second one? I mean, technically I did, right? Y equals mx plus b, right? But I didn't get any of the numbers, right? So the number that was like hidden there was the 12, or the 1/12.
What were you adding?
You didn't add anything. So b was 0. So just like in number 1, you notice how we didn't add anything in number 1? So your b is 0, okay?
Also, Luciano,
Yep.
can you go back to the objective? I missed it.
Yep. Your homework is on the last page. It's numbers 18 or 8 through 18, all of them. It's page 265 in your book.